Okay, lesson 54, solving simultaneous equations by substitution. Historically, this has been a difficult lesson, but we'll see what happens with you guys. Okay, you'll notice that we have two equations and two unknowns, and we need to find x and y. What these are, if you were to graph these, which we haven't done much graphing except for plotting points, if we were to graph these two lines, two equations, we'd find that they are lines that intersect in a common point. So if we graph them, we might have one line going this way and another line going this way, and the point where they intersect right here is called an ordered pair, x, y. It's an ordered pair that makes both of these equations true because it lies on both of their lines. So we're going to try to find the point where they intersect, which is the point that is going to make both of these equations true. There's several different methods to do this, and what we're going to do today is by substitution. We're just going to substitute in. As you can see, we have 2x minus y equals 1, but we have x solved by itself. We have x equals negative 3y plus 11. So what we're going to do is we're going to take what x is equal to. X is equal to this, and we're going to put what x is equal to in for the x right there. In order to solve an equation with two variables, you need to have two equations. You can't do it. You have to have as many equations as you have variables. So let's do our substitution. So we leave the 2 there, and instead of putting the x there, we're going to put what x is equal to in the second equation, which is negative 3y plus 11. And then we just carry on by writing what's left, minus y equals 1. Now the only variable we have is y. So because we have one variable and one equation, we can solve this. So we're going to distribute through. So you get negative 6y plus 22 minus y equals 1. And then we just continue to simplify this. We get negative 7y plus 22 equals 1. I'm going to move up here. We get negative 7y if we subtract 22 from both sides. We get equals negative 21. Divide both sides by negative 7. We get y equals 3. But that is not good enough. We need to find out what x is. This is just one of the points in the ordered pair. So we have to go back up. We're going to go back up into this equation right here, and we're going to put that value of y in for y. And we're going to get x equals, because we're trying to find x now, equals negative 3 times 3 plus 11, and we get x equals 2. So that is how you solve two equations simultaneously by using substitution. This is really the ordered pair where these two lines intersect. So if you're going to write them as an ordered pair, you put the x first, so it's going to be 2, 3. This is the value. You can put them back in here that will make both of these equations true. If I put the 2 in for x, I'm going to get 4 minus 3 for y is in fact going to give us 1, and it also works in the second equation. You can always check it to see if your answers are correct. Let's try another one. This one is solved for y. So we're going to take what y is equal to x minus 6, and we're going to put it in for the y. So let's do that. So we get 2x plus 3. The y is equal to x minus 6. See that? We're taking the y, and y is equal to x minus 6, so we're putting that right in there. Equals negative 13. Distribute. So you get plus 3x minus 18 equals minus 13. 5x minus 18 equals negative 13. Add 18 to both sides. and we get 5x. It's always nice when it works out. These all work out in Algebra 1. It's Algebra 2 where we get problems. We get x equals 1. We're not done yet. We have to go back up and find out what y is. We put that back up there. So we get y equals, we found out that x was 1, minus 6, y equals -5. So the point where those two lines intersect is an ordered pair, 1, -5. You could always figure this out by graphing. You could graph both of these lines and try to figure out where they intersect, and it would be this point. Let me go get another one. Okay, example 3. Try to move my screen again, which I can't do. Okay, let's just try this one. We're going to solve this. This time we have the x solved for, so we're going to put what x is equal to in for the x. Seems like the same thing over and over again. 3 times 3y minus 10 plus 2y equals 3. Distribute 9y minus 30 plus 2y equals 3. At any point you can turn the video off and try it yourself and then see if you get the correct answer. So you get 11y minus 30 equals 3. 11y equals 33, because I'm adding 30 to both sides. Y equals 3. Go back and find x. X equals 3 times 3 minus 10. And we're going to get x equals 9 minus 10 is -1. Okay, we have 2 more to go through. Okay. Why don't you try example 4 on your own, turn the video off and then turn it back on and see if you got it right. You guys all like to do this in class so much. Whoops, I actually lost the video there. Okay, try it. Okay, you should have got, for example 4, you should have got 4, -4. If you got that, you can fast forward. So you're going to plug in. This one's a little bit trickier though. You're going to see why in a second. So we're going to get -x minus 2 times y is equal to -3x plus 8 equals 4. Now check out this negative sign. The negative along with the 2 needs to be distributed. So you get -x plus 6x minus 16 equals 4. Combine your x's. 5x minus 16 equals 4. Add 16 to both sides, you get 5x equals 20. And we get x equals 4. Then you just take that back up here, and we get y equals -3 times 4 plus 8. You get y equals -12 plus 8, and y equals -4. And that's our ordered pair. 4, x goes first, then -4. Okay, this one looks interesting. It has x equals y. So what in the world do we do with that one? Well, we're just going to take our x and we're going to replace it with a y, or we can take our y and replace it with an x, either way. So let's take the x and replace it with a y. So you get 2y plus 3y equals 3. We get 5y. Are they going to give us a fraction, or did I do something wrong? Oh, this should have been a 5. This whole thing should have been a 5. Equals 5. So we get y equals 5 equals 1, and guess what? X is going to equal. If y equals x and y is 1, then x is going to equal 1. So our final answer to this one is 1, 1. So hopefully I didn't go too fast on that. I just quickly went through the examples and didn't give you a chance to ask any questions or anything. So that is it for lesson 54.